Hello students, welcome back to the class. In the last class, we studied about the magnetic field along a straight conductor which carries the current, and also we studied the magnetic field along a axis of the circular coil which carrying the current. So from this we concluded what is magnetic field, what will be the direction of the magnetic field, and what is the strength of the magnetic field when current is passing through a straight conductor, as well as when current is flowing in a circular coil. So these all the things we studied in the last class. And in the today's class, we are going to discuss the one important law for the magnetic field, and that is nothing but we are calling it as what? Tangent law. So we are going to study the what? Tangent law. Means what? We will study. So you know already the earth acts as a magnet. So when earth is acting as a magnet, no, it should have two poles. One is a north pole and another one is a south pole. This one already you know. Suppose this is the earth, and if it is acting as a magnet, then it should contain the two poles. One is the north and another one is the south pole. So let it be north and this will be south pole, I will consider. So if it is the case, if already it is acting as a magnet, then what I will do, I will take one magnet. So let it be, this is the magnet. So this magnet I will take and I will join the thread here. So with the thread, if I suspend this magnet in a free way, so if I suspend this one in a free way, no, then what will happen? This magnet will start to deflect like this, isn't it? So it will start to deflect and it will come to the rest position along the north-south direction of the earth magnetic field. So if a magnet is suspended freely on the surface of the earth, then it will start to deflect and it will come to the what? Rest position which is acting in a north and south pole. So the pole which is coming to here, this is considered the north pole, and this one is nothing but this one we will consider as the south pole. So this one already we know. Now what I will do, I will draw this earth magnetic field as already we are having, and that is called as what? Horizontal component of earth magnetic field. So let it be, I will draw, this is the horizontal component of earth magnetic field. I will denote by BH. So BH is nothing but what? Horizontal component of earth magnetic field. Already we are having this magnetic field. So whenever a magnet is suspended on this earth surface, then it will come to rest position along the north-south direction of the magnetic field of the earth. So that is along the what? BH it will come. So if I keep here the magnet, it will come to this direction. But what I am doing, I will change the situation. So what I will do, on this magnet, another external magnet I will create on the surface of the earth by using other magnets. So when we will create another external magnetic field, that should you take along the what? Perpendicular direction of the BH. So perpendicular means this is it perpendicular direction? So this one I will denote by B. So B shows the direction of the magnetic field which is perpendicular to the what? Earth's horizontal component of magnetic field. So BH is along there, along the x-axis, means along the horizontal direction, and what the magnetic field, external magnetic field we created, it is perpendicular to this one, means it is acting along the vertical direction or along the y-axis you can say. So it is there along the vertical direction. Now here two magnetic fields are acting. One is BH and another one is what? B. So two magnetic fields are there. Now another free magnet I will take and I will suspend this magnet in between these two magnetic fields. In between these two magnetic fields I will suspend. So if it is the case, then what will happen? This magnet will start to deflect like this. So after a certain time, it will come to rest position at a certain angle to the B and to the BH. So it will come to the rest position along like this. It will come, isn't it? So that time it is creating certain angle with the what? BH, and that angle we are considering as the theta. So now the magnet will come in this direction. Is it the direction? So this is the direction of the magnet which will come to the certain angle, and this angle we denoted by what? Theta. So understood clearly? So whenever only one magnetic field is there, and if you suspend a freely magnet, then it will start to rotate and it will come to the what? North south direction. Means what it is? Angle becomes 0 there. But when it is suspended between two magnetic fields which are perpendicular to each other, then it will start to deflect, and at one point it will come to the rest position which will make the certain angle, and that is called as what? Theta. So theta is the angle created by the magnet when it is suspended between two magnetic field. One is the earth horizontal magnetic field and one is the magnetic field what we created, what we are having the external magnet. So which are both are perpendicular to each other. So if it is the case, what the tangent law says? Okay, so tangent law will measure the ratio of these two magnetic field. It will measure the what? Ratio of these two magnetic field. So now we will find, means the strength of these two magnetic fields quantity it will give. So how to find that one? So what I will do, when it makes the angle theta, no, I will draw a triangle here. I am drawing a right angle triangle. So I will name it as A, B and C. So this is a right angle triangle we created between these two magnetic field. So if I take tan theta for this one, then you know tan theta is always equal to opposite by adjacent side. So opposite side is which? AB divided by, and adjacent side is which? So that is nothing but BC. So tan theta is equal to what we will get? AB divided by BC. Let's find the AB value and the BC value. So as along x-axis BH is there, so BC value is nothing but equal to how much? BH. That's it, taken it as the BH, because along the horizontal direction BH is acting. And at the same time, B, if you take, no, with the AB value gives along the what? Y-axis. So nothing but AB value is nothing but, we can call it as B, isn't it? So BC value is BH and AB value is nothing but what? B, because along the Y-axis it is there. So substituting these two values, so what we will get? We are getting tan theta is equal to B, AB value is B divided by BC value will be BH. So we got tan theta is equal to B divided by BH, and this is called as tangent law. So this is called as what? Tangent law. This one is known as the tangent law. Understood? So tangent law is nothing but what? Whenever a magnet is suspended between two magnetic fields which are perpendicular to each other, then the magnet will come to rest position at a certain angle theta, and for that the tangent of that angle gives the ratio of the magnetic field to the Earth's horizontal component of the magnetic field, Earth's magnetic field. So that is tan theta is equal to B divided by BH we got, and that is called as what? Tangent law. This one is called as the tangent law. So from the tangent law, we will measure the strength of these two magnetic fields. Means if you find the theta value, no, it will give the strength of these two magnetic fields in the ratio. And here BH is the Earth's horizontal magnetic field, and it is called as the projection of Earth's magnetic field on the surface of the Earth. So on the surface of the Earth is having certain magnetic field intensity along the horizontal direction, and that is called as what? BH. That is called as what? BH. Now the next point I want to say is what is horizontal component of Earth's magnetic field. Next I want to say about the horizontal component of Earth's magnetic field and how to calculate this quantity. So this is our concept, horizontal component of Earth's magnetic field. So already I said this is the earth, and along the horizontal direction if you take, this will give the horizontal direction of the earth magnetic field, that is what BH. Okay, so now if a magnet, if I take and if I keep in the horizontal direction, it will deflect and it will come to this position, isn't it? Suppose this is the magnet, and if I keep, it will start to deflect and it will come along the what, north south direction, like this it is coming. Now for this we suspended a magnet like this along a horizontal direction which is rotating this way. But now I will change to the vertical direction. So if it is the vertical direction, how it will rotate? It starts to rotate like this. So horizontal, it will rotate like this. So that one, if you keep for the vertical direction, so it will starts to rotate like this. So that is what the difference between vertical and horizontal direction means. What I want to say is, suppose a magnet is here, it will show this direction. Suppose if you keep here, it will show the direction like this. So any point on the earth, if you keep the magnet, it will show the direction like this, means it will act like this, isn't it? So all it will give the direction of the magnetic field like this. Means what? If you keep the magnet here, it will along this direction. At this position, if you keep the magnet, it will come to rest position with a certain angle to this earth's field, this ground surface of the earth. And if you keep here, it will come like this. If you keep like here, it will come like this. So like that, it will go on changing its direction on the point of the earth surface. Now if you join all this, so it will be looking like this. Is it? So it will be looking like this direction, which show the magnetic field lines. So these are nothing but the magnetic field lines created by the what? Earth, because earth is acting as a magnet. So now coming to find the horizontal component of earth's magnetic field, means nothing but which value? BH. So nothing but BH value we are calculating, horizontal component of earth's magnetic field. So for this we want to find the angle of dip. So if you know the angle of dip, from this you can directly calculate the horizontal component of earth magnetic field. So let's see what is angle of dip. Angle of dip is nothing but it is the angle between intensity of earth's magnetic field and the horizontal surface of the earth. So already we know the horizontal surface of the earth and the intensity of magnetic field, and that is nothing but, suppose this is the horizontal surface of the earth magnetic field, that is what? BH. Let's take, and the magnetic field intensity means when we will keep the magnet, it will come to certain position. If it is like this, it will come like this, but along a vertical direction if you take, it is coming to, and it is making certain angle with the BH. So that is what B I want to take. So this is the B and this is the BH we taken. So if it is the case, then what will happen? The magnet will come to like this, isn't it? So if it is not there, the external magnetic field, if you didn't create, only magnet if you take along the vertical direction, then it will make a certain angle with the horizontal surface of the earth, and that is we will denote by theta, and this angle is called as what? Angle of dip. So let it be B, magnetic field intensity what we created, and this is the horizontal surface of the earth magnetic field. So from this two we can calculate the theta value. So theta means angle of dip will be calculated by what? Again it will be B by BH. So tan of theta is equal to B by BH we calculating, isn't it? So now to find the angle of dip, we want to get two magnetic fields here. One is horizontal surface of the earth magnetic field, and second one is the magnetic field intensity, means the external magnet we are keeping. So when we will keep along the vertical direction, it is coming to certain angle. It will make certain angle with the earth surface, and that angle is called as what? Angle of dip. So angle of dip is nothing but it is the angle between intensity of earth's magnetic field. Intensity of earth magnetic field means this is intensity of earth magnetic field, and the horizontal surface of the earth. So this is the horizontal surface because along the vertical direction we got the magnetic field. So what the angle creates, no, this is called as the angle of dip, and from this angle we can calculate the what BH value, that is the horizontal component of earth's magnetic field. So this is about the tangent law and the BH value, determination of BH. So in examination for 2 marks they will ask this question. So for 2 marks means state the tangent law or state the horizontal component of Earth's magnetic field or define the angle of dip. So out of these 3 any one may come for the what 2 marks. So first thing, when they will ask the tangent law, no, you remember this equation, that is tan theta is equal to B divided by BH. So BH is the horizontal component of Earth's magnetic field and B is the magnetic field, which both are perpendicular to each other. So when they will ask the statement, no, you should say when a magnet is suspended between 2 magnetic fields which are perpendicular to each other, that is B and BH, then the magnet starts to deflect and it will come to rest position and makes a certain angle with the what BH. And if it is making angle theta, and if you find the tangent of that angle, then it gives the value or it gives the ratio of the B divided by BH. So that is called as what? Tangent law. So whenever a magnet is suspended between 2 magnetic fields which are perpendicular to each other, then it will come to rest position at a certain angle, and tangent of that angle gives the ratio of those 2 magnetic fields, that is tan theta is equal to B divided by BH. So you draw this triangle, this graph, and from this you derive tan theta is equal to B divided by BH, and which is known as the tangent law. So when they will ask the horizontal component of Earth magnetic field, define the angle of dip. If they ask, no, angle of dip is nothing but it is the angle between the intensity of Earth magnetic field and the surface of the Earth. So angle of dip is nothing but angle between intensity of, this is the intensity of Earth magnetic field, along the what horizontal surface of the Earth. This is called as angle of dip, and from this angle of dip we will determine the what BH value. BH is the projection of Earth's magnetic field on the surface of the Earth. So on the surface of the Earth along the horizontal direction, if you find the magnetic field, no, that is giving the what BH value. Okay, so in the today's class we studied these 3 things. First, tangent law, second, horizontal component of Earth's magnetic field, and third one is nothing but the angle of dip. So in the next class we are going to discuss the Helmholtz galvanometer. So for the Helmholtz galvanometer also we are applying the what tangent law, because there also the needle should come to the deflection and it will come to the rest position. So whenever magnet is coming to rest position, it is making angle with the BH, and that angle, with that angle we can readily find the what BH value. So if you know theta value and the external magnetic field, what we created is the B. So if you know these 2 things, then BH value we can calculate. So how to calculate that BH value? Tan theta is equal to B by BH, so which gives BH is equal to, so BH is equal to B divided by tan theta, B divided by tan theta. So B theta, when we know these 2 values, no, readily we can find the what BH value. So this is the calculation of BH. Like that you can calculate the B value also, means how much magnetic field you applied. So that is nothing but B is equal to tan theta, we will transfer this side, so we will get B is equal to BH into tan theta. So this is also the equation we are using in the what Helmholtz galvanometer. So the magnetic field is equal to the what? Earth's horizontal magnetic field into the tangent of the angle of suspension between the two magnetic field. So out of these three, any one equation you can use to find the all these things. Theta, use this angle, use this equation. BH, using this equation, and B calculation we will do by using this equation. So this is very important for the further study of the what? Helmholtz galvanometer. So remember the tangent law, horizontal component of Earth's magnetic field, and the what? Angle of dip. Okay, thank you.